Alright, so today we're going to be working on solving quadratics. And we're going to look at two methods. We're going to look at the quadratic formula and we're going to look at it graphically. So we're going to see how we can use our calculator to help us solve some quadratic equations. Alright, so we're going to look at two examples for this, and we're going to show you basically how to do each of them. One, use the quadratic formula, and then secondly, how do I use it graphically, how to use my graphing calculator to help me find the answer. So first example we're going to look at is x squared plus 5x plus 1 equals 2. Now in order to use the quadratic formula, our equation has to be set equal to 0. So the first step I'm going to do is subtract 2 from both sides. So I get x squared plus 5x minus 1 equals 0. In order to use the quadratic formula, as I mentioned, the quadratic has to be set equal to 0. So from there, I'm just going to use the quadratic formula. Quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So what I need to be able to do is from my quadratic equation x squared plus 5x minus 1 equals 0, I have to identify the a, b, and c. Okay, so my equation that I'm looking at is that kind of standard form, which is ax squared plus bx plus c. Okay. So when I look at that, I'm going to notice a couple of things. I know that a equals 1. Because the coefficient on the x squared would be 1. There is not a number there. It implies that it's the number 1. My b value is 5. And my c value is negative 1. Alright. So from there, I'm going to then just plug in those values. This is kind of a numerical way to do it. Plug in my values to my quadratic formula. So x equals the opposite of b. So the opposite of 5 is negative 5. Plus or minus square root b squared 5 squared minus 4 times a is 1 times c is negative 1 all over 2 times 1. Alright, so now I'm going to start computing. Get the square root. 5 squared is 25. Here I got to be a little bit careful of inside here. Negative 4, I'm going to treat this as a negative 4, maybe even make it plus a negative 4. Negative 4 times 1 is negative 4. Negative 4 times negative 1 is positive 4, so this becomes plus 4. 2 times 1 is 2. So I end up with x equaling negative 5 plus or minus the square root of 29 all over 2. Now, if I wanted to, I could turn these into decimals. So I'd have two answers. X equals negative 5 plus the square root of 29 over 2. And x equals negative 5 minus the square root of 29 over 2. Okay. So I'm going to use my calculator quickly to get those answers. So I have negative 5 plus square root of 29. Got to compute that numerator first and then divide that by 2. So I get one of my answers is about 0.19. My other answer is going to be negative 5 minus the square root of 29. again, compute that answer, and then divide that by 2. And so my second answer is negative 5.19. Those are just rounded answers. So if I come back over here, I get my two answers of x equals 0.19, about 1 point, or 0.19, and then x equals negative 5.19. So there's how you use the quadratic formula. Again, it's got to be set equal to 0, and then from there, I sketch my graph, or I use quadratic formula, identify the A, B, and C, plug it in and get my answer. And again, I just use my calculator to estimate the last two parts, 0.19 and negative 5.19. All right, so what we're going to look at is how could I solve this using my graphing calculator? And there's kind of two ways to do it. First way is if I look, what I'm really trying to figure out is where does x squared plus 5x plus 1 equal to? Okay? X squared plus 5x plus 1 is a parabola, a quadratic equation, so it's a U-shaped graph. And 2 is a constant. So really what I'm trying to figure out, and I'm going to really rough sketch this and then use my calculator in a minute to do it, is I've got x squared plus 5x plus 1. So let's just say it's, some parabola that looks like this. And I'm really trying to figure out when is that thing at a height of 2. And so I drew this horizontal line at a height of 2. I kind of trace it again. And so what this really means is I'm just trying to find the x coordinates where these two graphs meet. And as you can see, again, we're going to use the calculator to do it for real, but there they are. That's kind of the intersection. Right, so we're going to see how that plays out over here on the graphing calculator. So to use your graphing calculator, I'm going to go to y equals, and I'm going to type my two equations in. First one is x squared plus 5x plus 1. And our second equation is just 2. And I'm going to graph those. And here comes that parabola. And I was a little bit off on what it is. And there comes that line y equals 2. So again, you can see that I've got the intersection between these two is what I'm looking for. So to find the intersection, I'm going to use the second calculate button that is up by the trace button. So I'm going to hit second trace or calculate. I want to find where these guys intersect. So I want to go down to number 5, intersect. And what it's going to ask me is the first curve. Where is the first graph? So you can kind of see a flashing cursor. I'm going to kind of move it around a little bit. And right now the first curve is on that parabola. Okay, so I'm just going to move it. And you can actually hit enter right away, but I'm going to kind of start inching closer to that first intersecting spot and hit enter. Then it asks me the second curve. It automatically jumps up to the y equals 2 equation, so I can just hit enter. And then it wants a guess. As you can see, there's two spots where it crosses, so I just want to put my cursor, kind of close to the first intersection. And there it is. The x value is negative 5.19, where the y is 2. So my x answer is negative 5.19. And yes, that's what we found just a minute ago. So I'm going to do it again. Go back to second calculate and find that other one. So I'm just going to hit number 5 instead of arrowing down. And I'm going to arrow over. First curve, again, it puts me on the parabola. I'm just going to move over, get closer to that intersection spot. Hit enter. Then again, it puts me on that y equals 2 second equation. Hit enter, and I'm pretty close, so I'm just going to guess. And there it is, 0.19. Okay, so there's my two pieces I was looking for. The answers are x equals negative 5.19 or x equals 0.19. Okay, so you could, instead of using the quadratic formula, you could just go to your calculator, graph the two equations, basically graph the left side, graph the right side, and find where they intersect. So, all right, so let's look at a second example. For our second example, we're going to do x minus 2 equals x squared plus 3x minus 6. Okay, first time through, again, I'm going to use the quadratic formula. So I'm going to get this equal to 0. So I'm going to subtract x from both sides. And I'm going to add 2. So subtracting x is going to get rid of the positive x. And then adding 2 is going to cancel with minus 2. So that's going to leave me with 0 equals x squared. 3x minus x is a positive 2x, so x squared plus 2x. And negative 6 plus 2 is negative 4 or minus 4. So I get the quadratic x squared plus 2x minus 4. So again, I'm going to use that quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Again, identify my a, b, and c. A is again 1, b is 2, and c equals negative 4. Right, so plugging in, opposite of b, so opposite of 2 is negative 2, plus or minus the square root, b squared, so 2 squared minus 4 times 1 times negative 4, all over 2 times 1. All right, so I get negative 2 plus or minus 2 squared is 4. If I make this plus a negative 4 again, negative 4 times 1 is negative 4 times negative 4 is positive 16. 2 times 1 is 2. Adding 4 and 16 gives me 20 over 2. Now, there's a couple things I could do from here. I can actually simplify this if I wanted to get this to be an exact answer. Square root of 20, little side work here, from the simplifying square root video that you should have watched. Square root of 20 can be broken into 4 and 5 and 2 and 2. So I've got a pair of 2's, so I can actually rewrite this as 2 square roots of 5. So I can come back here and replace square root of 20 with 2 square roots of 5. There's my substitution. They're equivalent expressions over 2. And kind of the last thing I can do to simplify is, if you notice, I've got 2, or negative 2, 2, and 2, and they're all divisible by 2. So I can actually simplify and basically cancel out a 2, which is going to leave with negative 1 plus or minus the square root of 5. And that's what x is equal to. Again, I could go to my calculator, and let's do that just to get what those answers look like in decimal form. That way we can kind of compare it to the answers we get when we graph this. So I'm going to quit out of here. And I should have had negative 1 plus the square root of 5. So one of my answers is 1.236. And then the other answer is going to be negative 1 minus the square root of 5. And that answer is negative 3.236. Kind of see some similarities in the decimal places for that. All right, so let's just write those things down so we can confirm with the graphing calculator. 1.236 is one of mine, and x equals negative 3.236 for the second one. All right, so I'm going to go back to the graphic calculator. I'm going to sketch the graph of these two and see what they look like and find that intersection. So I'm going to go back to y equals, and I hit clear to get rid of that equation. I'm going to plug in the left side, which was x minus 2. That's going to draw a line. And kind of seeing the line pop in down in that middle graph picture. And then my second equation was the quadratic, x squared plus 3x minus 6. So pops that parabola. And then I'm going to hit graph. So here comes the line. Here comes the quadratic that comes in. As you can tell, in this case, they intersect twice. So again, I'm looking for the intersection of those two. So again, I'm going to go back to second trace, or second calculate, move down to number 5, or just hit 5. First curve, put me on the linear one, move it over, enter, enter on the second curve, and enter a guess. And there it is, 1.236, exactly what we got from -1 plus the square root of 5. Going to do it again, go back to second calculate, down to number 5. This time I got to move it all the way over to the other intersection spot. Close enough, probably. Second. And I'm going to slide it just a little bit closer for my guess. And there it is, -3.236. Okay. So again, same answers. That was the -1 minus the square root of 5. So a couple of different ways to get your answers for these. You can use the quadratic formula, more of a numerical kind of way. You got to be very careful with what's underneath the square root, called a discriminant. Again, I really like the idea of changing this -4ac into plus a -4. It might help a lot of you when you multiply that out to get that answer. So that's how you solve either graphically or using the quadratic formula for quadratics.